Welcome back to my channel. I am Dr. E. Navalita, Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology, Hyderabad. So today I am going to discuss a topic based on how to represent a binary numbers and what are the ways which you can represent the binary numbers. This is an important topic. In last topics we discussed that what do you mean by bits, nibble, byte, isn't it, and word. So now this is a very important topic for CSE, EC or any branch of engineering. How you are going to represent the numbers and those numbers, how it is going to work on your CPU. So number representation is very important because every electronic gadget which we take, all the electronic gadgets are made up of hardware and the software. And the hardware which you are going to use in your gadget is nothing but CPU, memory, input device and output device. So whatever the CPU and memory which you are using, those numbers will be working on the group of binary bits. Those group of binary bits will be used to represent the numbers which you are going to make use. So how many ways you can represent a number in the binary system, that we are going to discuss today. Because whatever the program you write to make the work on the hardware circuits, ultimately those program has to be converted into the binary bits, and the inputs for that task or the program you have to give in the binary bits. So here in this one, whatever the binary bit number, input number which you give, they can be either positive or negative numbers. Those positive numbers and negative numbers, how you are going to give in form of binary bits, that will be our discussion. Okay, so here today is representation of numbers in binary form. Okay, so whenever we go for numbers will be divided into two types. One is fixed point number system, second one is floating point number system. Okay, floating point number system. So whatever the fixed point number system is there, that fixed point number system is again divided into positive numbers and negative numbers. Okay, and again these positive numbers you can represent in two ways. One is signed magnitude representation and unsigned magnitude representation. Okay, negative number also signed magnitude representation and this signed magnitude representation can be represented in two ways. One is ones complement, another one is twos complement. Any number. So if you, I already discussed that number system will be divided in your computers is nothing but fixed point number system, another is nothing but floating point number system. Again in the fixed point number system you are going to have two numbers, positive number and negative number. If you take +4, This is the one positive number, the number which you are going to represent with the sign. Similarly, if you go for minus 4, same number you are representing with the negative sign. This is said to be the negative numbers. So whatever the numbers which you have in the positive and representation of the numbers in positive and negative numbers, that numbers which we call is a fixed point number system. And in this one, whenever we take a decimal point number system, think we have taken some 4.25. If the whatever the decimal point is there, if that is not moved either towards right or towards the left, then that type of number system comes under your fixed point numbers, and those numbers you are going to represent in positive and negative. And whenever we go to the positive numbers, those are going to represent in two ways. One is nothing but signed magnitude representation, another one is nothing but unsigned magnitude representation. So unsigned magnitude representation means whenever you take the sign, whenever you take the numbers without considering sign, if you don't take consideration of a sign, that is positive or negative, those numbers comes under unsigned magnitude representation. Whenever you take the numbers with respect to sign, like +4, -4, those numbers comes under your sign magnitude representation. Okay, so here in this one, positive numbers you can represent in the sign magnitude or unsigned magnitude. Whenever you go for negative numbers are represented with the 2 in signed magnitude representation. One is nothing but 1's complement, next one is nothing but 2's complement. Now we will see how we are going to represent these numbers in the signed magnitude representation and unsigned magnitude representation. So whenever we take a number in the form of m into r to the power of e, where m is a mantissa, r is a radix, and e is an exponent. Okay, so mantissa, m, r is radix, e is exponent. Any number which is in this form, that number we call it as a fixed point number. So if you take one number like this, 2.56 into 10 to the power of 2. Okay, so those numbers will be coming under your floating point numbers. So whenever you want to store a large number of numbers, then we are going for the floating point number system. Okay. So whenever we go for fixed point number system, already I told you, fixed point number system, any number which is expressed in p by q form, that is nothing but in that p by fraction, you can express in the decimal form like that, 2.56 or anything. So here this number, point whatever is there, if you are not moving either towards right or left, that is called a fixed point number system. Whenever we go for fixed point number system, we have two types of fixed point number system. One is signed magnitude number, another one is nothing but unsigned magnitude number. Okay, so think I am taking a +5 number. Okay, this +5 number, if you first you will consider in unsigned magnitude number. So first you will consider the +5. So whatever the +5 you are taking, that +5 If you write in the 4-bit binary form, if you write 4-bit binary form, how you are going to write here? So here 5 we are, if you take a 5 plus 5 means with sign consideration you are taking. If you take only 5 without sign consideration you are taking. So if you take the 5 here, that find the 4-bit, how you are going to write a 0 1 0 1, isn't it? So find the binary, how you are going to do it? Convert into binary number system. 2 2s are 4, 1 here present, 2 1s are 0, next 0 2s are, next is 2 0 0, 1 here 1. So what you are going to get here? Right from bottom to top, that is nothing but 0 1 0 1, isn't it? So here 0 1 0 1 we have written. So 5 in the 4 bits you have written in this form. So whatever the number bits you have written, those bits, this total is going to represent the value. That value only we are calling as a magnitude. Okay. So here in this one you are not at all specifying whether you have the positive number or negative number. Okay. So similarly if you go for signed magnitude representation. So in the signed magnitude representation, same plus if I take with respect to sign, same number. Okay. So this value, or you can call that value only magnitude here. So whenever we go for the magnitude with respect to sign plus 5. Plus 5, how you are going to write here? Same 5 I am representing the binary bits 0 1 0 1 in the form of 4 bits. In this one, whenever you take a group of bits, whatever the bit is there on the rightmost bit, this is called as LSB. LSB means least significant bit. Similarly, whatever the bit is there on the leftmost bit, that is called as MSB. That is nothing but most significant bit. So whatever the group of bits which we are taking, in this one whatever the MSB bit you have, this bit MSB bit will be taken as a sign bit. Okay. So this is represent the sign bit, MSB bit, and remaining whatever the bits are there in this one, that will represent the magnitude. That is nothing but value. Okay. So if the sign bit is having 0, then it is called as, then it will be taken as a positive number. Then leaving the sign bit, whatever the values there, that will be taken as a magnitude. 101 is equal to how much here? 101 if you take in the decimal form, 2 to the power of 0, 2 to the power of 1, 2 square. So whatever the 1 is there, that you take and add. 1 into 2 square, that is 4, plus 1 into 2 to the power of 0 is nothing but 1. So how much you are going to get? 1 into 4, 4, 4 plus 1 which is equal to 5. So here in this one, this is representing the 5 value. So if this magnitude, whatever the remaining bits are there, this is nothing but 5. So here sign is positive and the value is nothing but what here? 5. Okay. So this is whatever you get. This, that means with respect to the sign, you are representing the numbers. It is called as signed magnitude numbers. Similarly, same if you take instead of plus 5, if we take a minus 5, then what is changes we are going to do? Everything will be the same. Whatever the MSB bit is there, that is nothing but most significant bit. Instead of 0, this is going to hold a 1. Okay. So if the MSB bit holds 1, then that is taken as a negative number. And what will be the magnitude of the negative number? Whatever the value the remaining bits is going to hold. That is nothing but 101, that is representing 5. Okay. So this is, in this way you are going to represent the positive numbers and negative numbers of a fixed point number system. So whenever we go to the unsigned signed magnitude representation, how much value you are going to represent here? Minus 2 to the power of n minus 1 minus 1 2 plus 2 to the power of minus 1 minus 1. Okay. So whenever you go for unsigned magnitude representation of number, how much value of number you can represent in unsigned numbers? That is equal to 2 to the power of n minus 1 minus 1. So here I have taken how many bits here? 4 bits we have taken, isn't it? So n is equal to how much here? 4. 2 to the power of 4 minus 1 minus 1. 2 2 to the power of 4 minus 1, how much you will get here? Tell me. 2 to the power of 3 minus 1. How much it is? 8 minus 1. That is nothing but 7. So that means whenever you take how many bits? 4 bits. Okay. So here if you take the 4, whenever we go for this 4 minus 2 to the power of n minus 1, 2 to the power of n minus 1, 4 minus, no, this is not n minus 1, n, sorry, 2 to the power of n, 2 to the power of n minus 1, 2 to the power of 4 minus 1, that is nothing but 16, 16 minus 1, that is nothing but 15. That means whenever you represent the numbers in the unsigned magnitude representation of 4 bits, you can represent from 0, 0 to 1, 1, 1. This many numbers, that is 1, 1, 1 means 0, 0 means 0. 1, 1 means how much it is? 0 to 15, isn't it? So till that many numbers you can represent in the unsigned number representation. So what here they will ask, this is nothing but range of unsigned magnitude numbers. So what is the range of unsigned magnitude numbers? 2 to the power of n 2 to the power of n minus 1. What is n? Number of bits which you are going to take in your representation of numbers. How many bits you have taken here? 4. 2 to the power of 4 minus 1, how much? 2 to the power of 4 minus 1, that is 16 minus 1, that is nothing but 15. That means till maximum 15 numbers if you take 4 bits you can represent. Similarly, if you go for signed magnitude representation, the range of numbers which you can represent is nothing but minus 2 to the power of n minus 1, minus 1 to plus 2 to the power of n minus 1, minus 1. So if you take 4 bits, how much you are going to do? What is the range here? Minus 2 to the power of n minus 1, minus 1 to plus 2 to the power of n minus 1, minus 1. How much you are going to get it here? 4 bits means 4 minus 1, 3. 2 to the power of 3 minus 1, 2 plus 2 to the power of 3 minus 1. How much you are going to get? 8 minus 1, 7 minus 7, 2. 2 to the power 8 minus 1 means plus 7. So whenever we take 4-bit representation, MSB bit will be allocated. MSB bit will be allocated for sign bit, and the remaining bits whatever is there, this MSB bit is allocated for what? Sign bit. Remaining bits are allocated, that is 3 bits are allocated for representation of the value. How much values you can represent? Positive and negative numbers, minus 7 to plus 7. Minus 7, how you are going to write? MSB in the 4 bits, MSB bit is 1 and remaining bits will be equal to 1, 1, 1, its magnitude value. Similarly, if you go for plus 7, how you are going to represent? The MSB bit is 0 and its value is nothing but what? 7, 1, 1, 1. So in this way you are going to represent the numbers. Okay. So here in this, whenever you go for representation of negative numbers, so negative numbers in this one, you have signed magnitude representation, you are going to represent both positive numbers and negative numbers, isn't it? So here whenever you go for negative numbers, whatever you have, those negative numbers are represented in 2 ways. One is nothing but 1's complement, another one is nothing but 2's complement. That we will see now. So whenever we go for representation of signed magnitude numbers, I told you you can represent two numbers, one is nothing but positive number and negative number. If you go for negative number, it is represented in 1's complement and 2's complement. Now we should know what is 1's complement and 2's complement. So 1's complement, I think I have taken a number plus 6. Okay. So plus 6 if you take. Plus 6, how you are going to represent? Here I want to represent negative. First we will take the negative numbers. You can represent both in the two ways. One is a 1's complement, another is nothing but the 2's complement. So if you take a minus 6 instead of plus 6, this minus 6 you can represent either in 1's complement, another one is nothing but or 2's complement. So how you are going to represent in the 1's complement and 2's complement, that we will see now. So whatever the minus 6 is there, that you write in the, first you take plus 6. Here I am going to represent this plus 6 in the 4 bits. Okay, because it is plus means take it as a 0 MSB bit. 6 in the 6 you represent in the remaining 3 bits. Okay, 6 in the remaining 3 bits will be equal to what? 1 1 0. This already you know. 1 1 0, how you can write? 2 to the power of 0, 2 to the power of 1, 2 square. 2 square means how much? 1 into 2 square? 4. 1 into 2 square, 1 into 4, plus 1 into 2 to the power of 1 means 2. This is 0, no need. Wherever 1 is there, that corresponding value you take. 6, that is 6 means you can take it as a 1 1 0. Okay. So here in this one, whatever the plus 6 is there, MSB bit is this, that is most significant bit. This is nothing but your LSB bit. This plus 6 you have represented in the 4 bits. Here you can take minimum 4 bits, maximum any bits you can take. You can go for 6 bits, 8 bit, 12 bit, 16 bit, anything. So here in this one, here whatever the plus 6 is there, that you write down like this. And the sign, this is the sign bit, isn't it? That sign bit I am going to write it as a S here. So here you need to represent this minus 6 in 1's complement and 2's complement. In 1's complement, how you are going to write whatever the bits are there, that bits you take it in opposite. Here MSB bit, what you have? 0. You take it as a 1. Here 1 is there, you take 0. Here 1 is there, you take it as 0. Here 0 is there, this is 1. So this is nothing but 1 0 0 1 is nothing but minus 6 in 1's complement. Similarly, this minus 6 you can take in 2's complement. In 2's complement, what you have to do? Whatever the 1's complement you have taken, just you have to add 1. Add 1. 1 means what you are going to get here? That 1 you take in the 4 bits. 4 bits, 1 is nothing but 0 0 1. Okay. So then you take it as 0 0 0 1. Here full adder will be used in adding. Okay. So here it will be initially 0 0 1 1 means how much you will get. Remember that already in the previous videos I have covered full adder. In the full adder, here full adder will be used. 3 inputs are used. Among the 3 inputs, if 2 inputs are 1, what will be your sum bit? If among 3 inputs, 2 inputs are 1, what you are going to have? Sum is equal to 0, carry equal to 1. Among the 3 inputs, if 1 input is 1, then sum will be 1, carry will be 0. This everyone should remember. Among the 3 inputs, if all the 3 are 1, then sum will be 1, carry will be 1. Among the 3 inputs, if 2 ones are there, then sum will be 0, carry will be 1. Among the 3 inputs, if 1 input is 1, then sum will be 1, carry 0. Among the 3 inputs like this, all ones are there, then sum will be 1, carry 1. Okay. So here what you have here, 2 ones are there. among the 3 inputs. Here another input is not there, I have taken that as a 0 initial carry, because full adder requires how many inputs? 3 inputs you require. So 0 1 1 means how much sum bit you are going to get? Sum bit 0 as you have written here, carry bit 1. Again you have 3 inputs here. 3 inputs means how much you are going to have here? 2. Among the 3 inputs, one input is 1, means sum 1 carry 0. So sum 1 carry 0. If all the 3 inputs are zeros, remember that if all the 3 are 0, like 0 0 0, sum you are going to get 0 and carry is also you are going to get 0. So you are going to get here sum 0 and here you carry means next bit you have to send that. So carry 0. So 0 1 0 means again 3 inputs. So 3 inputs, among the 3 inputs, one input what you have? 1, sum 1, isn't it? Sum 1, next one, among the 3 inputs, one input 1 means sum 1 carry 0. Carry you place here. This will be placed in the carry flip flop. Okay. So what is the value you got? 1 0 1 0. This is nothing but minus 6 in 2's complement. Okay. So in this way you are going to represent the positive numbers and negative numbers. So in my next video I will show you how to add these numbers, positive numbers, negative number, and negative and positive number, both negative numbers. Okay. So here this YouTube channel is mainly I started because already I am working in a good profession, and as I felt most of the students are not getting the good concept in whatever the subject they are studying. So I have started this. So to support the professionals and students community and engineers, to help them to go for more people this video, please subscribe them, place a comment and click the like button. Okay. So to help the people only I have started this YouTube channel. So please support me and help as much as people as we can. Okay. So thank you once again.